Hello guys, welcome to another installment of How Do I? And today I want to talk to you about something that is immensely important to all of us, performance. Now, this is a big subject, so I'll try to cover it as much as I can, but still be relatively brief. So if you don't experience good performance with Codename 1, then please talk to us in the forums, check the developer guide, and go over other things. I'll provide as many tips as I can, but obviously the platform is huge and contains a lot of hidden information in it, and things sometimes don't act as you would expect. So let's go over the basics here of what the pitfalls people usually run into in performance. So let's start with lists. If you used a list and you made use of your own custom list model or list renderer, then there are several pitfalls within these two tools. So to explain that, let's look at the API itself. The API for the list model is here under list. And normally if you don't actually create your own model, then you shouldn't have a problem. The only problem you would have is if you have a list that's already showing on the screen. That if you have a list that's already showing on the screen, you might have a problem if you repeatedly call the default list models add item entry or remove item entry. And the reason behind this is that both of these methods are every time you add an item or remove an item, the list model needs to fire an event and notify the list. So if you do that repeatedly, add lots of items, remove lots of items all the time, then the data change event is fired to the parent list, and you're effectively causing lots of events. All of them trigger repaints and are very expensive, and they're very hard to pull. So to change a lot of data list, you're better off replacing the entire model than firing this event constantly. So that's really important if you're using the default list. If you implement your own list, however, you should make the methods like get and get item at be very, very, very fast. If you can't make them, if you connect to the internet or do any other heavy lifting sort of things, then what you should do is return immediately with fake data or any data, something, and then update them later on. It's crucial because these methods are called all the time and very frequently, and we rely on them being cached locally. This is hugely important, and you should observe that when making a network bound list or something like that and using the list model properly. The same holds true for the renderer. A common mistake people make is when they call the renderer component, they return a new instance of a component. Never ever do that. That sort of blocks your performance instantly, thrashes the garbage collector, and creates a lot of garbage, because this method is called a lot. It's not called per the number of the items, because we have animations within the list and things like that. It can be called repeatedly over and over and over and over again. So take that into consideration whenever you're building any form of interface on top of the list component. So those two things are really important, and I urge you to pay attention to them. The next issue is if you're doing any sort of drawing of strings or things like that. The string width method, which is supported by fonts and allows you to essentially measure the width of a string, is really slow on some platforms, not on all of them. And that's a feature of the platform, because actually measuring the width of a string is much more complicated than it might seem. You need to go through the glyphing process and everything. So That's one of the reasons why our label implementation isn't multi-line by default automatically, and why text area is much slower than label. So if you want to build something that's efficient, I suggest you use labels and not try to have line breaks automatically, because you would get far worse performance because of the repeated calls to string width. Now we have internal optimizations for that sort of make lots of assumptions and try to reduce the cost of string width, so it's not a log n of the cost, because you essentially need to measure every character's width. I digress. But still, automatic line breaking is far more expensive than you deciding in advance, okay, I want to break a line here. So don't rush string width. You'd be surprised how much of the performance costs we pay in Codename 1 is related to that particular method that's difficult to optimize. Bitmap fonts are deprecated in Codename 1. We recommend you use TrueType fonts for everything. They perform as fast as any font, but unfortunately they're unsupported in the low-end devices, in J2ME and stuff like that. So we are aware of some people still choosing to use bitmap fonts despite their many disadvantages, one of which is their performance. Surprisingly, they actually work faster than system fonts in some cases, but they work slower on other platforms, and it's a matter of it's really difficult to assess their performance on real-world devices. So we recommend people don't use them at all. They're more expensive in terms of memory. They're not internationalizable. They have many problems. So we just don't recommend people use them at all, and we have deprecated them. Small images doesn't seem like such a performance issue, and it isn't. If you're drawing one small image, then no big deal. It doesn't cost you almost anything to draw an image, small or large. The problem is when you draw small images and you draw lots of small images. So for instance, using a 1 pixel image and tiling it in the background, that's really, really, really slow. And the reason for that is how the GPU works. Essentially, every time you draw to the screen, you need to go back and forth between the CPU and the graphic processing unit. And going back and forth is really expensive for doing lots of small operations. You're better off doing larger operations. So in that same coin, it is much faster to draw an image than draw lots of lines or draw lots of graphic primitives. So you're better off just drawing a bitmap image that's as large as reasonably possible. Keep in mind that larger images might take more memory and might not look good on smaller device. And my next point about scaling is also very important. So anyway, small images are generally problematic if you choose to make lots of small image drawings. That's a big cost. That's why when we cut borders, we recommend you cut relatively larger portions of the border. For the 9-piece borders, see my tutorial on that. It's just much, much faster. And we find that this is a great piece of cost in terms of performance for some of our users. Now, image scale is an issue where images, if you invoke the method image scaled, sorry, I missed that here, it should be scaled really, not image scale. That method creates a new image that is essentially scaled to the given resolution. The thing is that this method, while it works, it produces not the highest quality image because it doesn't do any interpolation or anything. It costs you in terms of performance still, because we do all of this in Java code. But although it's relatively fast, the problem is twofold. The first, there's a problem in memory here. Once you invoke image scaled, you effectively get an image that is much larger in terms of RAM, The default images you get in Codename 1, and I suggest you read the image section in the developer guide. It's really complex, but interesting, I think, fascinating. The image section in that discusses it. Images don't actually take their full size. They take the size of the compressed image, the PNG or the JPEG that you chose, which isn't much. However, when you invoke scale, the image will automatically take up the width, the scale width you've selected, times the height, times 4, and possibly times 2 again for iPhone and other platforms. So that is a pretty huge size. So for instance, if you want to set a background image for an iPad 3, which is 2048 by 1536, then you'd have to do 2048 times 1536 times 4 times 2, because we keep the image twice, both in RAM and on the GPU on the OpenGL section. So don't use that method whenever possible. The substitute is to use the draw version. If we will go into the graphics section here, then you have a method which isn't ideal. Normally the best approach when working with icons and things like that is to use a method like when working with graphics like that, is to use a method like a multi-image or something like that when working with icons. But if you need something like scaling, we suggest use a method like this, which is automatically used when we set a scaled background or things like that. This doesn't have the cost of the RAM overhead, and it's better in general because it's usually handled by the GPU. On devices like J2ME, unfortunately, it isn't supported. So this works only with the smarter devices out there. The two last things. So the problem is in our developer guide that this is not always immediately obvious, that the round rect issue is problematic. The round rect issue is related to the fact that when we draw a round rect, that is really easy and simple, just drawing a round rect. The problem is when we combine it with a background image and transparency. And that's where things start to fail, because there is we don't have round rect clipping or the ability to construct things in such a way. So the performance of this is remarkably slow, and the memory overhead is. Use 9-piece images. Don't use this. This is really slow. We have it there mostly for historical reasons. We'll probably deprecate it because it is so slow. I would strongly recommend you don't use it and use instead 9-piece images. So don't use the round rect border unless you're doing something really trivial, and even then you're better off using a 9-piece image which is properly anti-aliased and etc. So don't use that, at least not in the current version of Codename 1. Last but not least is translucency. Translucency is really fast on modern devices. You shouldn't worry about that. It should work okay. Obviously, if you do lots of layers of translucency, you will pay for that, so take that into consideration. However, if you're targeting older devices, specifically Symbian, Symbian sucks in terms of translucency. This is a well-known issue with the Symbian devices. So just don't use translucent images or any form of translucency if you want good performance on a Symbian device. They are just really slow with it, and there isn't much we can do about that. That's a known issue with that device family. And the problem is that some of our themes use translucency quite heavily, so they won't perform as well on those particular devices. So you might want to optimize those themes. Now, to track performance issues is relatively simple. Just create a blank theme or a theme without that much information in it and try to reproduce the issue there. This often helps you in finding whether the performance is related to a theme element or to something within your application, and work through a process of elimination, trying to get an insight into which portion is causing the performance effect that you are seeing. Obviously, this isn't always a trivial case because without the theme, it is often harder to truly perceive performance. But sometimes that helps. So thank you again for watching this tutorial, and I hope you've enjoyed it and learned something from it. Thanks.